everyone, and welcome to Calculus Lesson 1-1, 4 ways to represent a function. Let's see what we have to review first. So we're going to start off with what is a function. So take a minute and think about what you remember about what a function is, and then we're going to go over the technical definition and what it actually means. The technical definition of a function is that it is a rule that assigns each element x in a set D to exactly one element f of x in a set E. So you may remember in Algebra 1 where we were talking about these, and what we would do is we would say if you have something in this box over here, the only thing it could produce is this thing in this box over here. So if my function was 2x, oops, my pen isn't working, just a second, is 2x, okay, and that's my function, and maybe I had a 1 over here, then the 1 would produce a 2 over here. And there's only one thing you can get from that 1 when you go into this other box. That's what a function is. Now let's talk about some other terms that relate to functions. The next term we have is domain. What is domain when we're talking about a function? So take a minute and think about what you remember about what a domain is, and then keep watching to see what the technical definition is and how we can better explain it. So the domain is known as set D of this function. It's the set of all possible inputs for a function. So what that means is anything that is in this box over here is part of the domain. It's the inputs of the function. Now we have another special word for set D, and that is independent variable. The independent variable is a symbol that represents an arbitrary number in the domain of a function. And basically, that's any number inside set D, any of those x values. Now we have one more term to talk about. Let's see what it is. Okay, so the last term we have is range. And yes, you probably guessed that. But take another minute, think about what you remember about a range, and then see if you're right. So the range, the technical definition, is the set of all possible values of f of x as x varies throughout the domain. So it's set E of this function. So it's all of the output values over here. So after I've taken my x value, I've done something to it, it's all of these output values. Okay, so we have a special name for those output variables, and that is the dependent variables. So all of the things in set E are dependent variables. These variables, or whatever variable is representing this output, is a dependent variable. So now we have an example, and this is going to be an exercise that you probably recall from other years, because we've done this quite a few times. In this one, we need to find the values of f of 1 and f of 5, and then find the domain and range of the function. So let's start with f of 1. Take a minute and see if you can answer these. So pause the video, see if you can answer this question, and then press play to watch me find the values of f of 1 and f of 5. So to find f of 1, all I need to do is start down here and find the 1. Here's the first line, and I just go up 1, 2, 3, 4. It's about at 4.5 right here. So that is 4.5. And I know that f of 1 is 4.5, or 4.5. Okay, now for f of 5, I would count over to 5. 1, 2, 3, 4, 5, right here. And I would see how high that is. And actually, it's at the 0 mark. It's right where it crosses the axis. So f of 5 is 0. Now for domain and range, you may recall that if the graph is continuous, like this one is, this is continuous. There are no breaks in it. It's not dots. It's a solid line. We use inequalities to show what we're doing. So the inequality for the domain, I would need to count from the lowest to the highest value for my x's. So the lowest value is 0. So I'd start off with 0. And I'd say that's less than or equal to the x, because that is my independent variable. And it's less than or equal to, now the furthest point over that it goes is 7. So I'm going to put a 7 right here, and that is my domain. For the range, I would do the same thing, except I'm counting from the bottom of the graph to the top of the graph. So for range, I would start at the very lowest point of my graph, which is approximately -2. So -2 is less than or equal to, this time I'm going to use a y, because y is the dependent variable. And then I'm going to count to the top, because I'm looking at the y's. So 1, 2, 3, 4, 5. The highest it goes here is 5. So that's the domain and range of this function.